Well, hi everybody. My name's Jonathan. People on the internet tend to call me Cook, and we're not going to go into why that is. But I wanted to talk to all of you about a problem that I think a lot of us are facing in Wiki world, and that is the fact that aggressive AI scrapers have made it kind of suck to run wikis. A little bit of background: I run Weird Gloop, and we host a bunch of video game wikis, RuneScape, Minecraft, League of Legends. We have a couple new ones since the last time I gave, not this talk, but when I had this slide. And we get about 10 to 15 million human page views every day, which is a decent amount, which should make it seem kind of crazy that at this point, the vast majority of our resource usage is spent not serving those 10 to 15 million page views and like 10,000s of edits every day. It's spent dealing with AI scrapers, and over the last 3 years or so, more and more of our dev time has been spent fighting bots, and this traffic is kind of all the things that you would hope it wouldn't be. It's spiky, it's disproportionately expensive requests, and it's getting harder to distinguish from humans. And if we weren't constantly mitigating this through a few techniques that I'm going to talk about through the rest of this, about 10 times more of our compute would be used for that than everything else put together. And I have a little graph here. I'm not sure quite how well it shows up, but the rate at which this has become a problem is skyrocketing. We're at a point where we have about 250 million, we think, it's at least 250 million requests from AI scrapers per month, and it is roughly quadrupled since the end of last year. So not great. This, of course, isn't unique to us. This is a problem everyone is having. It's really the exact same problem for everyone else. Wikimedia Foundation put out a few blog posts about this. Every major wiki farm has had varying degrees of service outages because of this. There's some smaller, like totally independent wikis that are just completely offline now. So that's also not really great. My estimate, this is kind of hand wavy, is that about 95% of all server issues in the wiki world these days are the result of AI scrapers. I've had a lot of people really in 2024, 2020, people have gotten the memo, I think, by now, but in previous years, people would say, oh my God, my infrastructure is screwed up, what's wrong with my database? And the answer is always, check your server logs, you're gonna see millions of requests from these things that are not actually humans. So what is this bot traffic? Like what is this actually functionally all about? I want to get into why this is hard, and I want to talk about 5 specific things that I think every wiki sysadmin that I've talked to is dealing with. So number one is these things are getting really good at pretending to be humans. Most of the discourse in sort of the wider media world is about things that at least clearly identify themselves, come from some of these frontier models. So GPT bot, Claude bot, Perplexity bot, all these things. And webmasters, of course, started blocking these when they didn't want the traffic, which incentivized both them and anyone else who isn't a frontier model but is doing sort of smaller scale things to pretend to be human. And that comes in a lot of different forms, and it's kind of turned into an arms race where these days most of the traffic you'll see will say that I'm Google Chrome 145 and I'm using a reasonable version of HTTP and my headers are good and my TLS ciphers are exactly what they would be if I'm actually Google Chrome. So all these things used to be really good signals to block on, and the easy wins have kind of been evaporating over time. Problem number 2, they're using tens of millions of IP addresses. So before 2023, you could usually block the traffic based on either this is a single IP or it's a subnet of IPs or it's at least like a ASN, like a larger group of networks. And that worked pretty well for a while. And then residential proxies showed up. And I assume most of you at this point know what residential proxies are. But if you don't, anytime some random teenager downloads a free VPN on their iPhone and it connects to their home internet, the reason it's free is because it's not actually free. They're selling your connection, which in fact is much more valuable than the data center connection. They're selling that to the highest bidder. So all of these requests that are coming to the Minecraft wiki, I shouldn't say all, but a large fraction of the requests that are coming to the Minecraft wiki are routed from we don't have any idea where to this kid's iPhone to us. And this is just, I don't actually understand how this is legal. Apparently it is currently. I'm hoping that is going to change.
That's not source of all residential proxies.
Sure. There's more organized things for sure out there. But I think that the fact that most of the people that are the exit nodes for these things don't even know that they're the exit nodes for it is kind of screwed up. And so it's pretty common these days to see a single scraper run that will cycle through 1 million IPs in a day, because this is happening at an industrial scale now. There's entire companies that are making millions and millions in revenue where this is all they do is they cycle through IPs. Another source of problems for this is Google and Facebook have a variety of tools. Google Translate, for example, you can put in a URL and it will tell you, oh my God, Cindy's here.
It sounded like you were saying it.
Okay. Okay, so Google Translate, for example, you can put it in a URL and it'll say, it'll make the request to that URL from one of Google's IPs. And people have figured out, well, we can just send millions of requests through this and they'll be abusive, but Google isn't going to be smart enough to block them. So this just gives us basically free open proxies that look legit because they're coming from Google's ASN. Facebook has some similar stuff. And it's just, it's not good. It's not good. Number 3, they're mostly crawling really stupid URLs, because the way this generally works is they are going to visit the home page of your site, then they're going to click all the links on that page, and then they're going to click all the links on all of those pages, continuing on and on until either the heat death of the universe or they just, I don't know, they eventually finish. And as a lot of you probably know, MediaWiki has a lot of navigable URLs. So you might only have 10,000 articles or something, but you're going to have north of like 1 billion distinct navigable URLs that means that this sort of breadth-first search process is just never going to finish. They never look at robots.txt to decide what to look at. They never realize, oh man, there's a sitemap that we could use. They just breadth-first search it, and it never ends because MediaWiki is somewhat uniquely, I don't want to say poorly designed because that implies that they should have known that this was going to be a problem, but it's more of an issue for MediaWiki than most other websites. And the thing is, these requests are expensive because usually it's going to do a full parse. If you're looking at an old diff, you're not going to be able to hit the parser cache or anything else. They're also really useless. That's kind of the crazy part to me, is I don't think these old revisions or looking at the history or looking at the 500th page of special wanted pages is actually providing any useful value for these LLMs, but they're still doing it. But one thing I really want to point out is that because these requests are unusually expensive, that means the top line metrics about the number of requests or the amount of bandwidth as a percentage that these bots are using tends to seriously undersell the size of the overall problem. And the reason is a lot of times the relevant factor is total CPU usage. Or you can sum that a couple different ways. But if we're saying, I think the top line number from Wikimedia Foundation's old post was 65% of our bandwidth is coming from this. But it's going to be a lot more than 65% of the total CPU usage, at least in our experience. I don't have their numbers, but I think that's going to be the same for pretty much everyone. And then the traffic is really spiky, so the aggregate metrics really undersell the size of the problem. I said we got 250 million requests a month, but that's just a long-term average. That's, what is that? That's like 100 a second, but a lot of times you're going to have 1,000 a second or 10,000 a second or more. And at some point, this is kind of indistinguishable from a good old-fashioned denial of service attack. And so these bots might only be, again, an example of this underselling the size of the problem. The bots might only be, let's say, 50, 80% of the aggregate CPU usage. But if you're consistently, let's say, using, I don't know, half of your CPU, that's fine. You're going to survive. It's a capacity issue, not like a throughput issue. The problem is when they're using too much of your resources for the rest of your traffic to survive. And that's what happens when we have these spikes. And again, like I said, I think, in my experience, this is responsible for about 95% of the server issues, let's say service issues that have happened on wikis in the last year or two. Last thing is, it's really not clear who's doing this. I keep calling them AI scrapers, which is probably true just based on timing, but with everyone pretending to be Google Chrome, I don't really know who's responsible for it. I don't know what they're doing with the data. I don't know if they're data brokers doing stuff for third parties. They might be frontier labs kind of double dipping to get more data. It could also, it's possible I'm just like underestimating where the bar is for getting access to these residential proxies. I assume that if someone is hitting me from 500,000 IPs, maybe they're some reasonably large actor, but it's possible that's just not true anymore, and this is where the script kiddie world has gotten to now. I don't really know. I've been like trying to find anyone who has an idea of where this data is getting slurped, and I have yet to find a reasonable answer. So if any of you know, please tell me. So I want to talk about what's mostly worked for us, because this would be the point where I would be like, this is a sales pitch, and we're switching gears, and I have some magic solution to sell you that is going to solve all the problems. I don't have anything like that. I think this is fundamentally just a very hard problem. It's a game of cat and mouse that is continuing to develop. But I do have some ideas that we've been using at Weird Gloop that at least partially work. And I think a big part of collectively solving these problems is being more open about the techniques that we've seen work and hopefully encouraging more people to also talk about that. So the most obvious thing that pretty much everyone on any sort of website is doing these days is you're going to use Cloudflare or you're going to use Anubis to do some sort of like proof of work based challenge on traffic that seems problematic. And this kind of works. It has two main problems. One is there's going to be like long periods of time where the bots are actually just able to pass the challenges. This thing where you think you're able to separate out the wheat from the chaff and stop the bad traffic is just fundamentally doesn't work. And so we'll have a week at a time maybe where we have a huge amount of traffic from Huawei and Tencent and all these other Chinese cloud providers where if we dig into the data, actually they're passing all of the challenges. So this is kind of a problem. And it's extra a problem because if the bots are passing them, that's one thing, but the readers also hate them. They really, really kind of hate them. So you're stuck back to this original problem of trying to come up with good heuristic rules for which traffic to challenge. How am I on time? Good. So in terms of what these sort of heuristic rules look like, everyone has some sort of handwritten heuristic firewall rules. The talk at the beginning of the day also was talking about how they're building different rules based on previous attacks that have happened, and it's saying, oh, if you're in this IP range and this specific user agent, and maybe you're from Vietnam, because that's where a ton of the problem traffic is happening, we're just going to block it, or we're going to at least challenge it. And this sort of technique, based on user agents, IPs, ASNs, that sort of thing, it worked okay for a while, and for the reasons I talked about earlier, it has stopped working quite as well. It's not very effective when a ton of the traffic is Google Chrome and it looks like it's coming from someone's home internet connection from Comcast. So as time goes on, we've had to use more and more complex attributes of the requests. So drilling down on the HTTP version, there's a number of headers for things that are attempting to be Google Chrome, where if they're not using those, you can tell they're fake Google Chrome. You can use just more detailed factors about the connection related to the TLS ciphers that they're using. There's, I think it's a commercial tool originally called JA4 that kind of combines all of this TLS information into a hash that is supposed to be unique, and you're supposed to be able to look it up and say, this is doing a bunch of bad traffic. In practice, we're kind of running out of good attributes of these requests to use to block stuff. That fell off the side because I converted it to PowerPoint. That's going to be fun. So one thing that we found works pretty well is if you look for things that the bots don't do, there's a number of essentially HTTP requests that normal people on real browsers do as a result of mouse movement, user interaction, that the bots just won't do because they're not, knock on wood at least, they're not scrolling around and just really interacting with the page the way that a real person would. The canonical example of this for me is the pop-ups extension, which is default on Wikipedia, is default on a number of different places, where if you hover over a link, it will add this little thing that gives you a preview of what is going to be on the page that you would click. And this makes API requests in the background. And it turns out if you look at the bots, they never, ever, ever do these, really ever at all. So if you see a chunk of traffic that is not doing these pop-up requests, but is still using a lot of your resources, hitting pages, whether they're hitting old diffs or not, it means you can probably challenge it. And this is actually a really, really powerful tool if you use it in conjunction with sort of old-fashioned machine learning techniques of building decision trees based on your source of truth being whether or not the traffic did this human activity that the bots don't do. And this is, we have something built that does this. I've hesitated to use it in production yet just because I don't know what sort of weird real traffic it's not going to play nice with. So anyone, for example, that is not using JavaScript would run into issues here. Anyone who is using a screen reader, I don't know kind of what all the edge cases are that we would break if we started challenging that type of traffic. But generally, the technique of sort of looking at this negative space, looking at the things, not looking at the things that the bots are doing, but looking at the things that they aren't doing is really effective. And there's other things, I'd be happy to talk about more specifics besides just the pop-ups thing that work for this. There's a number of other types of HTTP requests that you can use for this. There's some other ideas that I kind of like that we haven't done, but I've seen other people do. It turns out it's feasible based on network topology to identify residential proxies based on these discrepancies between the TCP timing and the TLS timing. There's a whole series of research papers and things about how to do that. There's also crowdsourced databases of residential proxy IPs, but in my experience, these aren't actually very actionable because they just, if you block all the residential proxy IPs, you're actually also blocking a fairly large portion of the real traffic. And this is really weird to think about, but if Cloudflare said all of these residential proxies are just going to be blocked, you would have like the greatest internet outage of well, since January or whenever the last one was. So there might be something actionable you can do with that. I don't know what it is yet. Someone else mentioned that these scrapers often have a limited number of connections. So if you can actually just saturate their connection pool and drip them like a couple of bytes every second, just long enough to make them not end the connection, you can kind of eat them up without a ton of resource usage on your side. There's also like commercial solutions. Cloudflare has this heuristic bot management stuff. A lot of other people have these systems that feel like they should work because they have enough data, both from like crowdsourcing all of these different customers, and they just have a lot more low-level, like packet-level network data. In my experience, none of these have really worked very well, and I don't have a clear idea of why that is. I've tried not to talk about that part too openly because I don't want Cloudflare to come like cancel the contract we have with them. But I don't know why crowdsourcing plus network packet level information doesn't solve this better than it seems like it does. Although Cloudflare did add some new fields literally today as I was writing this. So I don't know if those are better, but it might help a little bit. There's also some big ideas, these nuclear options that I don't really like, that I've seen other people use. One is you require everyone to log in to view any of these pages that are potentially expensive. So that's things like diffs, history pages, special pages. Another one is you can just serve Cloudflare challenges to all of the traffic. So you make everybody mad, but you probably, at least when the challenges are working, you stop most of the bot traffic. And I think both of these are understandable things to do if you're a webmaster, but I think they have really bad long-term consequences if you're trying to build wiki communities. All these little things where you're adding friction, adding barriers to entry, requiring people to log in, they really add up. I think more than any of us, all of us, okay, maybe not all of us, most of us have been doing wiki stuff for a very, very long time, and we've forgotten what it's like to have no idea what you're doing, and we've forgotten how much little tiny things like, oh crap, I need to make an account to do this, instead of just editing without that, how much that adds up and kills the funnel of new contributors over time. And I did a little analysis of this on Fandom, who was one of the groups that hid all the expensive pages and made you log in for them. And I found that the exact day that they did this, there was an immediate noticeable 40% drop in contributions from new editors. Not like bots, like actual real people that just saw that and were like, I'm not gonna bother. So where do we go from here? The whole situation here is not feeling great at the moment. It's what now? There's a couple different end games that I could see happening. One is there's this kind of constant arms race between the bot owners and the webmasters, and I think that's probably going to continue until someone figures out how to change the structural incentives around crawling. And one possible way that that could get solved is, and I kind of hate this because my preferred outcome would just be to have the crawling stop and unring that bell and never have to deal with that again. If that's not the case, one possible solution to at least keep everyone's sites online is to have some way that is the least friction way for these kind of bad actors to get the data, to get the relevant data, not the old diffs, but the actual pages, to get it in a way that is easier for them than going through residential proxies, than crawling it through whatever means they want. There's a new API from Cloudflare that came out, I think like 2 weeks ago or something, that I think is them trying to solve this problem that way. They're not really presenting it quite as that, but I think that's what they're attempting to do, because if they can make it so that using their API, which I'm sure they're going to make money off of, is less effort for the bots than having the bots build their own systems that ignore robots.txt and are super spiky and cause all these problems for us. If that ends up being less friction than building your own thing, I could see that being sort of a reasonable way that this ends up landing okay, even though people have reasonable suspicions about centralizing so much of this infrastructure within Cloudflare. But the reason I'm personally optimistic about this is that everyone I've talked to is dealing with this and has their own little clever things that try and solve this in their own way. There's literally thousands of people out there. It's not just wiki people, of course. This is a problem that's affecting the entire internet. And everyone's finding more and more clever ways to deal with the bots. And I have to assume there's a lot of discussion happening in places that I don't see, random Discords and Slacks and conferences like this. I really wish there was more public discussion about the practicalities and the techniques around blocking this traffic. I think a lot of sysadmins I talk to don't realize just how much their problem is the exact same as everyone else, and not even in like a vague sense, in the sense of literally this set of IPs is hitting you guys and it's also hitting us. So if you're a sysadmin dealing with AI scrapers in really any sort of capacity whatsoever, consider sharing just what has worked for you. And I think as much as, I think everyone has a bit of a concern about losing the arms race by telling everyone what worked for them. I think it's clear that the current way of doing things isn't really working. And so consider sharing what's worked for you, and talk to me, talk to whoever about this, because I guarantee everyone is dealing with this. So thank you, that's the talk. Yay, scrapers.
Well, Cindy, our actual program chair is here, but I figure I'll serve as quasi program chair for at least this one last talk. Yeah, okay.
Lovely talk. Thank you so much for getting the conversation kick-started for this conference, because this is super important. This is causing me to continue to lose sleep, even after complaining about it in Sandusky last year. So we do have an element slash matrix chat called WART. What's it called? What's it stand for? Wiki? Yeah, wiki something. We named it yeah, anti-response, whatever. We named it because we felt like artificial intelligence defense system wasn't going to be a very good name for it. Anyway, anyway, but yeah, we've been discussing a lot about stuff on there as well. And on Friday we're going to have that crawler protection roundtable discussion. But yeah, there's so much that I'd love to share. You know, a lot of these techniques that you're saying that are becoming less and less effective, that's a really good thing to know for now. And let's try to, you know, collaborate. I know that you tried to not name check crawler protection, which thank you. But I'm open to, you know, improving crawler protection. I'm open to exploring other ideas. But yeah, let's collaborate. Let's all work on one thing. This is something that we really cannot afford to splinter on. So, yeah.
No, I agree with that.
Thank you.
Oh, okay.
Thank you very much. It was very informative. There's one thing that didn't exist, so I vibe coded something, and there's almost no downside. It's like when all else fails, basically what it does, it monitors the server load, and when it gets super high, it will interact with the Cloudflare API, and it will actually activate UAM temporarily, and then it'll keep on monitoring the load. So when it goes down, which it will pretty quickly, it'll put it back, and it'll kind of go back and forth. Now, obviously, UAM is under attack mode. That's what gives you that challenge that asks you if you're a human or not. Nobody likes it, but what they like worse is the site is down. So it's something I created that fights bots, and it's kind of like a no downside last resort kind of thing. And also mentioned, I'll maybe touch on this kind of thing in my Kubernetes talk tomorrow. Maybe I'll work some stuff in.
Yeah, I think you're raising a really good point, which is that a lot of the best defenses for this are not static, but are actually responsive to whatever is currently happening. You know, whether that's looking at the server load or looking at you know, the last 5 minutes of your Nginx logs to figure out what the heck's actually going on. Like there's a lot of really emergent techniques that work pretty well if you're willing to say it's going to change in response to traffic that is coming through.
All right. Well, this talk has generated very few questions, but a ton of comments, including on the YouTube channel, of lots of people offering their own prescriptions for dealing with the problem. And actually, we have 2 talks on Friday that deal with the same issue in various ways. One from Jeffrey and one from Giuseppe Lavagata, who does this for the Wikimedia Foundation. Yeah, was that? Yeah, that's it. All right.
Cool.
Thank you.